Okay, welcome back to the Unit 1 packet. So we started off with section 1.2, talking about functions and graphs. I already did the first part, so we're going to go to the second part of the lesson. Let's focus on graphs of functions. We graph functions the same way we graph equations. Remember, whether it's straight lines or parabolas or any kind of squiggly lines, they are all composed of points, also known as ordered pairs. So we find ordered pairs xy, or as in function notation we would call it f of x. Remember that the y is the simpler way of saying f of x. We plot points and connect the points with a smooth curve. That's as it's going to show in the next example. In example 2 here, we're going to graph the function f of x equals x squared minus 5. And if you recall from Algebra 2, that anytime a function has a degree of 2, like squared, that it's going to form a parabola. So, the basics of it would be getting points by filling a table. So these x values are chosen for you already. So we are going to fill out the table using the function and the x's that are given to us. So the first x input is -3. So we would say f of -3 equals -3 squared minus 5. And then that would be 9 minus 5 is 4. So that 4, we tend to call the y coordinate. We can also call it the f of x if you really want to be formal with it with function notation. So that forms the point -3, 4. So we will go plot that point now. -3, 4. Let's do my second one here. -2 is going to go in for x. -2 squared is 4. 4 minus 5 is -1. So when x is -2, f of x is -1, and it forms the point -2, -1. -2, -1. Next is the input x is -1. So that'll be 1 minus 5 is -4. So it forms the point -1, -4. And then I'll just fast forward a little bit. If you plugged 0 in, you would get 0 squared minus 5 is -5. So 0, -5. One plugging in would be -4. So that's 1, -4. Sorry for the bad handwriting. And 2 squared minus 5, that'll be -1. 2, -1. And the last one, 3 squared minus 5, that would be 9 minus 5 is 4. So 3, 4. So don't do connect the dots with straight lines. You're going to throw in a nice little angle. You want some curvature down here at the vertex at the bottom. And mine's a little choppy because I'm not an artist at all. So anyway, that's using a table to graph functions. Let's try another one. Actually, we're not going to graph this one. We're going to take a look at what you're going to see in the homework. So a graph is shown for us already. We don't know what the function is. Who cares? We are going to be given some directions that say find f of -5, f of -3, f of -1, 1, and f of 3. What does that mean? Well, that means what they're doing here is we have 5 little mini problems, and it's telling us to find the points, and they're telling us what x coordinates of those points are. Let me show you what I mean. So let's start on the first one, f of -5. So we look over here and go, -5 is here on the x-axis. That traces up to this point here. What is the y-coordinate of that point? It's right there, staring you in the face. 5. So f of -5 equals 5. It's so much easier than they make it look. Okay, let's do another one, f of -3. So we're looking at -3 right here on the x-axis. That goes to this point here where it traces down to. Its y-coordinate is -1. So f of 3 equals -1. We're just finding out what the y-coordinates are of points. And those are, remember, called outputs. All right, next, f of -1. So this time the x is -1. That traces right here, traces down here. So that's the point. -1, -3. So -3 is the output. Next, f of 1. X is 1 here on the x-axis. That goes to this point here. 1, -1. So -1 is the output. And then finally, f of 3. So that would be right here. That goes up to this point, 3, 5. So when x is 3, f of x is 5. 3, 5. So it's pretty much just filling in the blanks for points. It's very, very easy stuff. You guys actually did do this in Algebra 2. You probably just forgot about it. So that'll set you up with the first half of the today's assignment. So next up, we're going to talk about if something is a function or not by using what's called the vertical line test. So if an x coordinate, domain value, is paired with 2 or more y coordinates, range values, the correspondence is not a function. Points on a graph sharing a common x coordinate are vertically above or below each other. I'll show you what I mean there in a second. So the vertical line test is to test whether something is a function, yes or no. If it is possible for a vertical line to cross a graph more than once, then the graph is not the graph of the function. So we would put no, it's not a graph. So example 4 says, which graphs are functions? So we're going to put yes or no for each of those. So we are trying to make it fail for a no. We don't just assume everything's yes. So far, if I drew a vertical line anywhere, I can't draw anywhere on here that would go through more than one point. So that would be a function. Now letter B is going to be a no. If I drew a line here, that would cross more than one point, actually 3 points. But if it crosses more than one point, that would be not a function. It's failing the vertical line test. Letter C, what do you guys think? Yes or no? That would be a no. It crosses more than one point when we draw a vertical line. So we failed that. That's not a function. What do you guys think of letter D? Letter D, if you said no, you were correct. If you drew a vertical line, say here, it would cut through more than one point. Failing, it is not a function. What about letter E? Letter E would be a yes. That is a function. You can't draw a vertical line anywhere there, and it goes through more than one point. And the last one, F, that's a little bit tricky. What do you guys think? Is it a function or not? That would be a yes, it is a function. Now some of you might be thinking, what if I drew a vertical line here? However, that would be That doesn't fail the vertical line test, because see this guy here, how it's an open circle? That means an open circle means it's not actually filled in. It's not part of the graph. It's just kind of like an invisible wall where it stops. Okay, so that would pass the vertical line test, and it is a function. Okay, we're going to stop there today. We're keeping this video short because the next one's a little bit longer. So you guys should be good to do the parts of your homework. What did I just cover today? I covered numbers 5 through 7, and I covered numbers 8 through 15. So 5 through 15 I covered today. All right, guys, be good, make good decisions.